In this video, I'd like to demonstrate the fact that with LogoPress 3, we can do lots more than just die design with it. We're going to create a new project with a job number of 9-22, and it's going to be called Gage. And we'll hit save, and that starts the new tool. LogoPress loads 3 new subassemblies. And we'll start out by adding a plate into the middle assembly, and the plate that we're going to add, we're going to browse for it. It's going to be the bracket. That's the part that we're going to be designing the gauge for. And so we'll hit OK. And the next part we're going to add is going to be in the lower. It's going to be based off the die block template, which is nothing more than a rectangle, and we'll call it gauge base. We'll give it, excuse me, A2 material 5860, Z position minus 2.25, enter, and we'll hit OK. And so that's been put into the assembly. Change it to 8 inches that way and 0.75 that way, and add another plate. And this one's going to be called a small block. Or it's going to be based off the small block, gauge block. And this one will be A2 as well. Also 5860, Z position is here. X position will be superimposed from here. And Y position will be 0.125 adjacent to this surface. And we'll hit OK to that. Yes, I understand I'm creating it in a different subassembly, and I need to change my Y, reverse that, and then make that, let's see, the Y dimension, excuse me, a bit longer and a bit taller. And next, add another plate. This one will be side gauge, and the material, heat treat, Z position, X position will be adjacent, Y position will be 125, and that's superimposed from here. And OK to that, and make that just X dimension 0.25 and Z dimension 1.75. Add another plate, back gauge, and this is going to be the go no-go block, and X position is going to be superimposed from here, and the Y position will be adjacent to here. And hit OK. And we need to make that a bit taller. So that's the Z dimension. That looks good. And the X we're going to make only 1 inch wide. And add another. And this one is going to be the L gauge template. We'll call it L gauge. And a Z position of, let's see, superimposed right here, and it's going to be 250 tall. And the X position is going to be right here, and the Y position will be, let's see, that will be superimposed 0.125 from here. And OK that, yes, I understand. Thank you for reminding me. And that's good. And that has a gap in it like we want it right there because we're putting preload on that. Okay, and we'll then go and edit this block, edit part, start a sketch on that surface, and switch to wireframe mode, and back to there, and offset by 0.250, hit OK. Stretch that, this way and that, and do a cut extrude. And that's the go, no-go area right there, of course. And let's see, in the front, so we'll stop editing that, and then we'll do a machining axis hole. And I'll move that over next time so you can see it better. And this is going to be a blind hole, 0.2405. 1 inch deep is fine. Hit OK. Zooms us in normal too, so we're ready to put a sketch point on that. And hit OK to that. And there's our hole. The next hole, and again, okay, you can see machining axis here now. The next hole is going to be in this surface here, and it's going to be a counterbore type hole. And the small diameter is going to be 0.501, and the big diameter is going to be 0.64. And the L1 depth will be 1 inch. And then we need to reverse that hole. That is going to be for our pilot pin that will locate this part front to back. And excuse me again, this is a standard component we'll add to it. And we want to pick a different standard component. We always start with a socketed cap screw. We'll put a conical head pilot in there, a Dayton versatile inch, 1/2 inch diameter, and 625 long. And then we'll also put a little bit of preload on it, 0.562, so you can see it drop down because there's going to be a spring there. And other plates cross through, we'll select that. We're not going to have a through hole though. We're going to have a blind hole. It's going to be 0.64 and 0.5 deep. Into that hole we will add a Raymond free length spring. And that will be a 5/8 diameter. And it will be 1.5 long with 0.250 preload. There we are. And that's done. And now we're ready to get into sketch mode and add our sketch point to that. So that sketch point is going to go right there in the center, of course, and OK. And now we're going to add our machining axis on the side of this hole. This is going to be a 1/4-20 tap, 0.75 deep, drilled. And the standard component we're going to add to that hole is going to be a shoulder bolt. It's going to be 5/16 diameter shoulder bolt, and it's going to be 1 1/4 inches long. And hit OK. And then we'll add another standard component to that. And this one is going to be a fin washer. It's going to be 5/16 diameter, and it's going to go up against that head. And then you can see that we need to switch the alignment of the mate. There we go. And OK to that. And now we add another component yet. And this one is going to be a Raymond die spring. And it will be a Raymond, and it will be 5/8 diameter and 1 inch medium duty. And let's see, the face for that will be right up against here. Let's hit OK and actually, let's see, modify that and select this face. It's not liking that, so we'll just hit OK to that. And OK to this, and automatic pattern, but select only one point, and it'll find the absolute center of that, and hit OK. And we'll come back to that spring in a minute. I'm not sure why that's giving us grief. And let's see, now we'll go and put some screw holes or some socket head shoulder, or I'm sorry, cap screws in here holding this gauge on. And that's okay. And let's position by two edges, make them 0.5 from the first pick and 1.125 from the second pick. So the first pick will be here, second pick will be here, first pick is here, second pick is here, and OK to those, and OK. And next, socket head cap screws for holding down this back gauge. What we're checking with the go, no go. OK to that. And automatically pattern. Change to 0.250 there, and OK. And next we'll put some dowels in that same plate. Doweling from here to here. And we counterbore that nicely, or counter drill that for you. And automatic pattern. And we'll bump that up. And we could easily offset one of these right now, but I'm not going to bother. Doesn't matter if that gets turned around, it's a gauge, it's not going to smash like if it were a die. Okay, let's see, that's screwed down. I guess we need to screw this one down. Socket head cap screws, and here to here. You can see that we're automatically determining the length for you, always 1.5 times minimum engagement, maximum of 2. And automatic pattern. Change to 4 places, and change to 250 by 250. Okay, and now let's offset this one because you can see it's breaking through that hole. So we'll move it up about like so, and okay. Actually, another 1/8 inch, I suppose, and okay. And then dowels for that one as well, of course. Dowels, click here and here. And OK to that. Position by two edges. And let's see, 0.25 by 0.75. 0.25 there, 0.75 there, 0.25 there, and 0.75 there. And OK, and OK. All right, now let's see if we can fix that spring. Let's save this, and let's take a look at our assembly. Collapse. Yep, everything is nice there. Okay, let's click on that and go back into Editing Machining Axis and click on this and modify that standard component. And now we're going to select this face, and there, now it worked. So I'm not sure exactly what was going on right there. And let's see, we'll give that 0.06 travel. And we might end up needing a beefier spring, but we can just add some washers to here. And OK. And the sketch was fine, we just need to change that face for the spring. Let's see, now we will go back into Tool Structure and add a plate. And this time we're going to add an assembly that we're going to browse for. It's going to be a go, no-go pin. And let's see, A2, okay. Z position, we'll just leave that as we will the X. And the Y position, we will pick this face. Hold down the Shift key so we can get it. And OK to that. And then we'll go to the mates here, and we're going to delete the X mate, and we're going to delete the Z mate. and we're going to change, we're going to add a mate. Actually, the Y right away, let's change that to be 1.750, or I'm sorry, 750 deep. And now we'll add a new mate. And in the assembly, we're going to choose this hole. And for the part, we will choose this. And there we've got our concentric mate. And as long as we're here, we can adjust some other things that we've got excuse me, defined as LogoPress features, or LogoPress template dimensions, I should call them. Change that, and the horizontal location, let's change that to 3.5. Oh, that's way too much. 2.5. Yeah, that's better. And 13.5 in that way. And now we've got some length on the gauge, but of course we're just going to make that to suit as well. Okay, and add another plate. And this one, again, we're going to browse for that. We're going to insert a Destaco clamp. Open that. And Z position, we're going to pick the top of this surface right here. And the X and Y, we'll just leave those as they are for now. And the clamp comes in. And first of all, we'll set some dimensions on the clamp. We'll change that to be 90 degrees. And we'll, let's see, spindle Z offset. So that's basically the material thickness. That brought that up. And let's see, that adjustment, that backs it away like that. So that's fine. And now let's change our mate for that. Actually, the X mate, I think we will back that up. And this is the X and not the Y because of how the clamp was originally designed. And the Y, we'll change that as well. Wrong way. And look down from the top. That looks good. Close enough. And let's see, we need to change, give focus up here so we can choose this plate, and then change the plate size here a little bit, or actually the X mate of the plate. Let's make that -2, too much. So bump that up a little bit. We don't want that to hit, but actually we're going to need to add some length to this too. So let's change that to 10 inches and then bring this down some more. Again, we've got a bunch of gauges on the shelf. We don't want it getting knocked off because a clamp arm gets caught or whatever. Okay, that's good. Let's see. Let's change the mate to back this up a little bit. Let's see, that's the Y mate. Okay, that's good. Alright, that's nice. And let's see. Now we'll add a riser for the clamp, so we'll add a plate. And this is going to be the lower, it's going to be a small block. And it's going to be clamp, whoops. Highlight that, clamp riser. And it will just be cold rolled steel. Z position is here. X position, again, because of the way the clamp is designed, is here. But actually that's superimposed. And the Y is also superimposed. And that's right here. And OK to that. And we need to make that a bit thicker, so it's the same thickness as the main plate that we picked, and smaller. So we'll drive those dimensions right here and right here. Whoops, too far. Okay, and let's see, do we have one more thing we'll add? I think this is the last, is one more plate to add, and we'll browse for this. and it is the nameplate. And here we'll just pick right about here, and then say put it on the pick point and on the pick point here. So you can just visualize something, and so you don't have to mess around mating it. And it is mated, but it's based on our pick points. Okay, that's it for tool structure, I believe. Right click, collapse, save, and let's see what's left. We need to put some screw holes in here, of course. Socket head cap screws starting from here, going into this plate, and they're also crossing through this plate. And now we pick the screw head plate and we say don't create those holes because the clamp already has holes in it. And OK to that. It zooms us in very nicely. Change the wireframe, and we'll put a point there after we wake that up. Wake this circle up. Wake this radius, I should say. Wake all of those up, and OK. Change back to shaded with edges. OK, and we need to screw down these two things. So we'll use some button heads for that. And head plate, tapped hole plate, and again, this already has holes in it, so we don't create those holes. And hit OK, and we get a nice preview. And again, we'll go to wireframe and select point, and put one here, and one here, and move over with our motion controller to here, and wake that up, and OK to that. And start showing our shading again. And let's see, so this is screwed down, that's taken care of, that one's screwed down. Okay, everything looks good. Oh, one more thing. Let's go into Standard Component Library and go to Machining Axis. And on the back side here, let's change to tapped hole, quarter 20, tapped all the way through, and add a standard component to that. And the standard component we want to add is a jig foot. And we're going to make it a 3/4 diameter with a quarter 20. And we'll make it 0.75 long, and change the length of the screw to 1 inch. And that looks super. And OK that. And OK that. And that puts us into sketch mode where we'll automatically pattern it. And bump that up to 0.5 and that up to 0.5. And OK. And OK. And there's our gauge. Just under 25 minutes. We've modeled up a nice efficient gauge. And I've done this gauge a couple of times before just so that we wouldn't waste your time. But again, mostly I just wanted to make sure you understand how we mate things, how we bring them in, etc. So thank you very much for your time. Let's do a drawing for this gauge now. So we'll go to Assembly Drawings, D-Size 3 View, hit OK. And there's our drawing. And we'll take this and put it up in the corner a little bit. And move this one over a little bit. And let's highlight this one, give it focus, and go to Drawings, and do Insert Drawing View Projected. And go to there, and excuse me again. Let's change this to half scale without hidden lines shown, so it just looks nicer. And then let's also click this and throw some balloons on it real quick. Auto balloon that view. And that's nice. And now let's see, we'll hit OK to that. And then go to select that and select the LogoPress 3 whole table, or actually bill of materials, I'm sorry. And we can deselect some parts from here using this list to say don't select the screws. Excuse me, and the list gets shorter, of course, and other things. Don't select dowel pins. Let's see, everything else we probably do want selected. So we'll OK that. And after having OK'd that, it's generating the stock list, or the bill of materials, I should say. And we set it right there. And then we take it and move it up to there, and move this one up to here. We won't snap together because the one on the bottom, let me move this over just a little bit. The one on the bottom is for purchase components, so it's not mixed up with the one on the top, which is for steel components and machine components. So that's designing a gauge and making a quick drawing in LogoPress. So thank you very much for your time.